I'd like to take a moment to review some analytical techniques on solving radical equations. Very useful in the sense that we don't always have this opportunity, so I thought this would be a good time to talk about it. So taking a look at 7 minus x to the power of 1/2 plus 1 equals x, I know it doesn't look like a radical equation, but when you have a rational exponent, another way to write it would be to look at the index as 2, and the radicand would be 7 minus x taken to the first power. Now we can ignore something taken to the first power, it's itself, so I can erase those parentheses. So I'll have this plus 1 equals x as well. And now we have ourselves, we can actually see the radical expression here. So when we solve radical equations, the first thing we want to do is make sure that you are isolating the radical. So I'm going to subtract 1 on both sides. And if you don't mind, I'm going to rewrite it without the index because we already assumed that we have a square root. So I have square root of 7 minus x equals x minus 1. Now, because we have a radical equation, a nicer way to find an equivalent equation that's a little nicer for us to solve, we can raise each side to the power of the index. So if we do this, what happens is the radical disappears in a sense. When you take the square root and you square it, you end up with the radicand. Now we can't say the same for the right-hand side. We have a binomial square, and what that means is that this binomial gets repeated and we must multiply. So if that is the case, what we'll do is we'll simplify this by multiplying x times x, gives us the x squared. X times -1, -1x, -1 times x, another -1x, and -1 times 1 is +1. We'll take a little time and clean this up. We have x squared minus 2x plus 1. And all along the way, this left-hand side never changed. So now at this stage, I'd like to point out that we do have a quadratic equation. And so we will follow the techniques of solving a quadratic equation by moving all terms to one side with 0 on the other. I find it nicer to move the 7 and the x over first. A little easier on that sense. So that will leave you with 0 on one side and x squared minus x minus 6 on the right side. So now if we're going to solve our quadratic equation, if you don't mind, I'm going to move it a little higher so that we have a little more room on the paper. And also, if you don't mind, I'm taking the liberty, I will rewrite so I have the quadratic expression on the left side and 0 on the right. Now, we'll see if we can factor. And it looks to be in a nice form. Factors of -6 that add up to -1. We can choose 3 and 2, and I believe there'd be a negative on the 3. So now if we factor, the only possible way to make a 1x squared is x times x. And this is good news, so we can use our factors directly. So this leaves us with x minus 3 equals 0 or x plus 2 equals 0. We add 3 to both sides, we'll get x equals 3. And we subtract 2 from both sides, we get x equals -2. Now I do have to caution, these are what we call potential solutions. And with potential solutions, we must check our answers. I don't know if I explained it earlier, but just in case, I'll repeat myself if I did. When you raise both sides of the equation to a power, sometimes you introduce extra roots, and we call these extraneous roots. And while this technique that we were using gives us a much nicer equation to solve, we have to account for this at the end of the problem by checking our solutions that we get. So we'll do that. Take this off to the side a little bit. And so what this means when we check, we're going to plug this back into the original equation. And by original equation, it means before you took any super crazy algebra steps. I'm going to use the radical form because that's a little nicer on my eyes. So that is the square root of 7 minus x plus 1 equals x. And pretty much what we'll be doing is we're just going to test them out to see if we're getting true statements. So I'll start off with x equals 3. If I plug this in, I'm saying 7 minus 3 plus 1 equals 3. And remember, it's a question, we're not sure yet. So when we do simplify the 7 minus 3, we get square root of 4 plus 1 equals 3. We're still not sure yet. Square root of 4 is 2 plus 1 equals 3. Yes, it does. So that gave us a true statement. So that means that we do have this x equals 3 is a true solution. We will do the same thing for x equals -2. And so I'm going to plug this in. I have square root of 7 minus a -2. Be careful there. Plus 1 equals -2. And again, it's a question mark. Now, if we take a little time to simplify, we have the square root of 9 plus 1. Still not sure if it's -2. Except we'll kind of notice, oh yeah, square root of 9 is 3. 3 plus 1 is never going to be 2. That is false. So because we got a false statement here, we know that x equals -2 did not check, so we remove that from our potential solution list. So we finally have the solution to this radical equation. I see that it's circled. It's great if you crossed out the other one, but if you do want to restate it formally, the solution to this equation is just one single number. It's 3. So a nice example of solving a radical equation analytically.